Okay, good morning, everybody. This is the recorded session for class. All right, the Wi-Fi outages, as you know, will have prevented us from having class earlier, but I'm pre-recording it just the same. Okay, so I'm going to screen share now. Here we go. Let's just go to our notes. Excellent. Okay, so in the previous class, I gave you some homework. We were to help SpongeBob figure out some questions. All right, here we go. So the question was that, firstly, let's review. Carl can eat 4 pies in 8 minutes. We said simply to find how many pies Carl can eat in 1 minute, it needs to be done using the principle of rate. So you half the amount of minutes to 4. That means he ate half the amount of pies, which is 2. So Carl can eat 2 pies in 4 minutes. Khalil brought up saying, okay, sir, since I can do the half there, I can go even further and say if I have, again, the amount of minutes from 4 to 2, half the pie, 2 to 1, so Carl can eat 1 pie in 2 minutes. But remember, I told you the definition of rate is for every one. For every 1 minute, for every 1 hour, for every 1 pie. Okay? But in this case, we have minutes as the rate. So we want to know for every 1 minute. So the rule is that we go even further until we have how many pies is done in 1 minute. So we half it once more, and we find that in 1 minute, Carl can eat a half of pie. 4 in 1 minute. All right. Okay, so using that example now, we moved on to use method 2, which was the actual calculation, not just halving every time, but we formed an equation or a fraction, so to speak. So in the case of Carl eating 4 pies in every 8 minutes, that was a fraction of 4 divided by 8. We said therefore to find, so this was minutes, to find the rate in 1 minute, right here, we essentially said 4 divided by 8 is equal to the unknown divided by 1, and we therefore said that it can be solved by dividing 4 by 8 using long division. So we say, here we go, let's put a 4 here, okay, put the 8 outside. We say 8 into 4, can't go, 0 times. 8 into 40, however, goes 5 times. So that means it's 0.5 or a half. And that's how we did method 2. Okay, then I gave you some examples to do for homework, which was express each of the following as a rate. The first one was done for you. 280 words for every 5 minutes is equal to 280 over 5, and that's the expression for the ratio. I didn't ask you to find for every 1 minute. That was done for the second part of the homework. So expressing that, the first one, the second one, 300 cents for mangoes. Jazeel a while ago told me it was 300 cents divided by 5 M's or 5 mangoes. Now in this homework, it says a student reads 24 words in 15 seconds. How many words did the student read in 1 second? To find the amount of words that student read in 1 second, we need to say, right, 24 divided by 15. So we do the long division. I know this is a little bit rough to see, but let me just clear it up a little bit. Let me enlarge the size of this to be a little bit larger. 1 second. Okay. Okay, great. Okay, and here we go. So we had originally 24. That was the only thing we had. Okay, we said 15 into 2 can't. 15 to 24 though, you can go 1 time. 15 times 1, that gives us 15. So therefore, we had now, right, 15. So 24 minus 15, that gives us 9. Okay, saying on 15 to 9, you can't. You add a 0, bring it down, put a decimal point right here. And you said no, 15 to 90 goes 6 times. 15 times 6 gives you The same. So that means you know it's going to be the answer of 1.6. Now this 1.6, right, is how many words that can be read in 1 second. Okay? So, therefore, the amount of words that can be read in 1 second is 1.6 words. Right? Then the next question now didn't just ask you for the first 1 second, it asks you for 5 seconds. How would you solve this? Let's bring back the 1.6 words per second. How would I find the amount for 5 seconds? Well, simply, per means 1. So you would need to write the fraction, 1.6 divided by 1. And I need to find 5 seconds. I'm going to multiply 1 by 5, but the rule is to also multiply the numerator by 5. And that tells me the rate of how much words is spoken in 5 seconds. So it would be 1.6 multiplied by 5. Let's calculate this. Eight. Okay, so 8 words was spoken in 5 seconds. And that was the homework. Okay, but for today's class, I want to talk about, let's cover up all the homework. There we go. Proportion, which is on page 118. So in page 118, it shows you 2 things, proportion and direct proportion. Okay, let's enlarge this a little bit. All right, let's bold it as well. There we go. And let's go into proportion and direct proportion. Now to explain proportion, obviously we can't be at that date. We need to go to today's date. So I'm going to go back and go to our today's date, which is Friday the 15th. There we go. Right. So we did the homework revision. We did how many words spoken in 5 seconds. So SpongeBob knows it is 8 words per 5 seconds. Good job, SpongeBob. All right, let's move on. So proportion. Here we go. So to explain proportion, I'm quickly gonna play this video. Let's zoom in.
Concept of proportion is very simple. All we need to do is understand a couple of simple examples. Assume you have a computer screen of the size 40 centimeters by 30 centimeters at home, and you've been asked to draw that screen.
Let's repeat that. Right? Listen close.
Concept of proportion is very simple. All we need to do is understand a couple of simple examples. Assume you have a computer screen of the size 40 centimeters by 30 centimeters.
Let's write that. Assume that we have a computer screen of 40 centimeters by 30 centimeters. Okay, we're just gonna do this class example. In the next class, I'll go more in depth.
At home, and you've been asked to draw that screen in your notebook.
Okay. Let's draw it in our virtual notebook. Drawing. So let's draw that virtual computer screen. Let's put it in blue ink. All right, and I know my drawings are gonna be perfect, but not to worry. Let's draw it. So I'm just gonna go there. All right, let's go. This is the first time my drawings has ever looked this good. All right, let's go across. There we go. And then finally, let's go down. Perfect. I would buy this from Apple if they were selling. Okay.
What do you do then? You cannot draw a 40 centimeters by 30 centimeters screen in your notebook.
Okay, so if you had a ruler, right, you would notice it has some measurements. So I'm gonna ask you, Go for your ruler and read the two types of measurements shown. All right, that's your homework. I'm gonna put hashtag activity. Hashtag activity. What are the two types of measurements on your ruler? And. Okay, I'm not gonna say the words. Okay, so when you find that measurement, it's pretty impossible to draw out the entirety of 40 centimeters. I told you one, my bad. But the next one you need to tell me next class. Okay, it's impossible to draw out such a long measurements on your book. Right, your book is only like 11 centimeters across or so forth. Right. So what you would need to do is have the drawing done in proportion. So we're gonna say using proportions, we can draw large objects to a smaller scale, such as in our notebooks. That's why you read a book and you see those drawings that I said, not in scale, not to scale, right? But it is proportionate. So it does look like a building, okay?
Your notebook would be too small for that. So what you do is scale the size down.
Right.
This term is very important. You scale the size down.
Let's write it down. Let's highlight the word scale. There we go.
It means you draw a smaller figure which is similar to the earlier one. You may draw a small screen like this, with length 4 centimeters and width 3 centimeters.
Okay, so we're gonna put now, instead of 40, we're gonna put 4. Instead of 3, I'm sorry, instead of 30, we're gonna put 3. Right? So your job is gonna tell me what is the amount of scale that was used. When we say scale, we really mean how much is the drawing reduced by. Right? So if it's going from 40 to 4, what's the difference there? If it's going from 30 to 3, what's the difference there? All right? That's what we mean by scale.
This will fit into your notebook. Here, the ratio of the length to the breadth is 4:3.
Okay, let's write this. It's very important. So we're gonna say the ratio of the length. Let's repeat that.
Meters and width 3 centimeters. This will fit into your notebook. Here, the ratio of the length to the breadth is 4:3. If you
repeat that one more time.
And width 3 centimeters. This will fit into your notebook. Here, the ratio of the length to the breadth.
Breadth. All right. Breadth. The word breadth. Let's highlight it. It's a new word for today. Breadth means. Let's put breadth. Here we go. The word breadth means the same as width. We're gonna say word of the day. Words of the day. So, all right, there we go. There we go. So we're gonna put words of the day. Excellent.
Is 4:3. If you had a bigger book, you would have maybe scaled it down to 8 centimeters by 6 centimeters. In this case, the ratio of the length to the breadth would be 8:6.
Right.
Let's talk about the first case.
Okay, so I want you to take note of the pattern. You organize the larger value to the smaller value, because you're saying for every 8, there is 6, right? The original measurement was 4 to 30, 40 to 30, and you scale it down to 4 to 3. So it's the larger one, which is 4, to the smaller one, which is 3. This is a visual
Why
example.
4:3? The ratio of the length to the breadth of the actual computer screen is 40:30. When reduced, it can be written as 4:3. Basically, if we divide both the numerator and the denominator by 10, we get 4:3. Now let's look at the second case of 8:6. The ratio of the actual screen was 40:30. If both the numerator and the denominator are divided by 5, we get an equivalent ratio of 8:6.
Okay, so now we're going to form a definition for our proportion. Let's understand now using the definition of proportion. So a proportion, therefore, is a statement, right, or an equation that two ratios are equal or, put it in bracket, equivalent. All right, equal or equivalent. Because if you look at the 40 divided by 30 and it's turned to 8 divided by 6, being that I divided by both values, 40 by 5 and 30 by 5, it is equal on both sides. That's why it's a ratio. If I was to divide 40, right, by 2, so let's use an example. Let's create another ratio of the computer screen. We're going to say 40 divided by 3, we're going to divide by 2, so 40 divided by 2, and then 30 divided by 2. All right? And let's figure out another computer screen size. So we're going to say 40 divided by 2, that gives us 20, and 30 divided by 2, that gives us 15. So another ratio that we could have used is join 20 divided by 15. Everybody understands? Well, you gotta tell me if you understand next class. Okay, so that's the majority of what I want you to understand. Okay, understand that a ratio is just making something that was large to a proper scale based on your condition. Okay, so page 118, we're gonna quickly now take some activity example. Okay, I have a picture that I took of the book. If you guys don't have the book, just to make sure we're on the same page. Here we go. So it says, let the width of the magnified painting, right? So the painting that it's talking about, let's write what it's saying. So let me give you the question. The question says, question 1 states that we have a painting of 60 centimeters by 45. Let's draw that painting. It's gonna be, here we go. It's a magnificent painting, I know. I'm gonna put now 60 by 45. Okay, so this is our painting, and it says A, if the painting is magnified so that its length is 90 centimeters, find the new width. And what do we say another word for the width was? Nobody's answering? It's gonna be the breadth. Okay? All right, so here's what we're gonna do. And the next question we're gonna go into after, but let's do the first question first. So it says, if our painting is magnified by, so if the painting is magnified, so that its new length is 90 and the original was 60, what is the new width? So it's changed from 45. So here's what we're gonna do. So since the new width would be unknown, meaning that we don't know what the value is, call it X. All right, so we're gonna call the unknown X. So therefore, putting the original painting as a proportion, we would have, let's look back on this, 60 divided by, 90 divided by 60. So we would have 90 divided by 60. Okay? Hold on one moment. This needs to be changed. 60 divided by 45. My bad. 60 divided by 45. There we go. So the original would be 60 divided by 45. Okay? And then it says now the new painting has a length of 90. So putting it as our new proportion, we're going to say the length is going to be unknown. The length is going to be 90, but the width is unknown. All right? So putting both lengths that we know together, the lengths that we have are 60 and 90. The widths that we have are 45 and X. We're bringing back the X. Okay, so here's what we're gonna do to solve this question, to solve this unknown value. Okay, we are gonna say express the lengths as a fraction. What was the two lengths? 60 and 90? Okay, here's the new fraction. We're gonna put 90 divided by 60. And then now, as you can tell, we're gonna express the width as a fraction. And what do you think we're gonna get? The unknown divided by 45. Okay, is that what we have here? Great, that is what we have. Okay, so I'm just giving you an idea as to how this applies to the real world, because after we know this value, we're gonna say X can be solved, right, to give us 90 divided by 60. So what we did here was to move this 45 by using remember that word? So the next word of the day, let's go back to the words of the day. Next word of the day is transposition. Transposition means carrying over a value, right? And just to give you an idea, when we carry this value over, since it was dividing here, right? To get this value over here, we would, let me write a fraction to show you, because you guys are doing fractions, so we could really go through this. All right, look at this fraction for me. Let's break this down. Okay, so we have X divided by 45. So picture 45 as like a brother, right? For you to get rid of that brother, all right, so he doesn't bother you anymore, you need to find his twin brother. So you multiply him by his twin brother. We did this last term, right? So when you do this now, both of the brothers are gone. I think they're gonna play with each other now. So whatever now we had left over here, which was 90 divided by 60. So this is what we had earlier. Let's put it in black. 90 divided by 60. This 45 is gonna come back. The brother now is over here because the rule is wherever we do on one side, we do on the next. So in this case, we multiply the right-hand side by 45 as well. Okay, all right? So we're gonna solve this fraction now, and that will tell us what our unknown x is. Let's go here we go. So our unknown x is gonna be solved by this value. Okay, let's simplify our fractions to calculate this. We're gonna simplify our fraction. Let's go in red. All right. 30 can go into 60, or in other words, 3 can go into 6, and also 3 can go into 9. So 3 can go into 6. Let's put this. 3 can go into 6 2 times, or 30 can go into 60 2 times. Right? Then now we're going to say 3 can go into 9 3 times, or 30 can go into 90 3 times. Right? So this is the same as 90 divided by 60. We call that equivalent fraction. So now we multiply this 3 divided by 2 times that 45. Times 45. And now we can work it out easily because all that we need to do is multiply 45 by 3. So 45 by 3 gives us 135. And then we just have the denominator below it. 135 divided by 2. So that's our improper fraction, right? To solve this improper fraction, make it a mixed number. The mixed number principle we said was to long divide. So let's check it. Let's long divide here. So we're gonna say 135 can go into 2 can go into 135. So 2 into 1 you can't. 2 into 13 can go 6 times. Right? So let me rewrite that. So we're gonna go 2, 135. Right? 2 into 13 we said can go 6 times. 2 times 6 is 12. Right? Remainder 1. Then we're gonna bring down the 5. Then we're gonna say 2 into 15. Right? That goes how many times? 7 times. Right? 2 times 7 is 14. Okay, remainder 1. But you can't have 2 into 1. 2 into 1 goes no times. So we're gonna put a decimal point, right? And bring down an imaginary 0. Let's put it in red. Imaginary 0. But it's gonna be real. Okay, from everywhere down here, This 0 appears, and then now we say 2 into 10 goes 5. So the answer is 67.5 or 67.5. The answer is 67.5 or 67.5. 67.5. So what is this value? Why is it important? Well, let's go back here, right? So that means, let's repeat the question. What is the unknown width? If I have a length of 60 and a width of 45, what's going to be the new width when the length is 90? Okay, think about it. If I'm increasing one side, based on what we said proportion was, which is when everything is equal. Let's go back to the definition of proportion. Proportion is a statement or equation that when two ratios are equal, two things on both sides are equal, right? So in order to make 60 and 45 and 90 and the unknown equal, we need to add something above 45 to make it larger. Because if the length is larger, the width has to be larger as well. And we found out that the new width is going to be 67.5. So that's it for the question there. I don't want to go in too much in depth, but that's the main idea and everything you need to understand about proportions. To really get the idea home though, I'm going to give you one question for homework. Hashtag homework. Hashtag homework. Put it here. Hashtag homework. If the painting is reduced so that its width is 30 centimeters, find its length. Okay? So use the ratio of the original painting, which was 60 by 45, and attempt this question. All right, everybody? So I'll see you guys next week, and let's see how well you did this question. Take care.